Okay, so in this video we're going to go over a property of logs. The first property is the product rule, right? So it's our first one. So let's just kind of review some of the just general properties of the logarithm. Right? If we think the logarithm and the exponential, right, they're very connected with each other. They're inverses of each other. So in the terms of inverses, right, they kind of undo each other. Right? So a lot of the properties that we have in exponents are very similar to the ones in logarithms, right? Not similar, not exactly the same, right? But we will use the exponent properties to help us derive new logarithm properties. All right, now, if you recall here, some things about the exponential, right? When we had log base b of 1, regardless of the base, right? This was equal to 0, right? And this was true because b to the 0 is equal to 1, right? That was just the definition of our logarithm. Right? Now another important one, when we have the argument is the same as the base, that is always equal to 1, right? And that is true because b to the 1 is equal to b. All right, so those are some properties of our logarithms. Right, now we also have the inverse properties, like when we take almost like the composition of them, right? The inverse properties. Right, where we have log base b of b to the x, and that is the value of x. Right. And again here, take for example log of 100. Right, remember log no base, it is implied that it is 10, so if we can rewrite this as log base 10 squared, which is 100, so what this law tells me is, oh, the value of this is 2. Right, and then the other property here, b raised to log base b of x, that is going to be equal to x. Now for this one, since we do have a domain restriction for the log, this is true because x is greater than 0. Or excuse me, this is true when x is greater than 0. Okay. All right, and then for this, if we had, let's say, for example, e to the natural log of x, then the value there would be x. All right, again, as long as x must be greater than 0. Okay. All right. One other property here that will come in handy a little later in this module is this one-to-one property. All right, and it stems from the fact that the function is one-to-one. What that allows us to do in terms algebraically is if I have something like this, when I have one log equal to a log here and then some expression inside the arguments of the logs, well, due to its one-to-one nature, I can just worry about solving the inside expressions, right? I can worry about solving for x by simply solving for solving this equation, right? Without the logs, right? And again, this is only when it looks like this, one log equal to another log. And again, if we have other logs, these properties that we're going to introduce over the next few videos, they'll help us get it to this form. Okay, so that is the one-to-one property. Okay, so let's kind of bring it back to what we wanted to talk about here, and that is the product rule. So the product rule for logarithms. All right, so when we say product rule, what we're referring to is for the argument, right? Mn being two arbitrary numbers. I want to establish a property that this log has, right? So the way I'm going to do that is I'm going to define lowercase m to be equal to log base b of capital M. And I'm going to define lowercase n to be equal to log base b capital M. All right, now due to the inverse property, or just the property of logarithms, this I can write as b to the m is equal to capital M. And this one I can write as b to the lowercase m. Okay. All right, so now let's develop here our property. So I'm going to start log of mn, right? That's our product rule. And I'm going to do some substitution, right? I define log of mn to be this. All right, so that'll be m log, base b of b to the m times b to the n. All right, now using properties of exponents, I can consolidate this here. All right, I can write it with one base, right, and the exponent being n plus n, and then that property that we went over now here, where we had the inverse property. In this case, x is this sum m plus n, so that is equal to m plus n, and substituting back here, the lowercase m is actually log base b of m plus log base b of capital N. Okay, and that is our product rule. Here, let me get a new sheet of paper here, and let me restate that product rule. So what we've shown now is that the product rule right, if we have log base b of n times n. Now again, notice here n times n, so we're talking about the argument of the logarithm, right? Not multiplying two logs together, right? That is not what we're doing here, right? We're looking at the argument. If I have something like this, then I can expand it to write it like this. Or I can go the other way, right? If I have a sum of logs, right, I can treat it as a, excuse me, all right, I can treat this as a sum, and I can write it as a product of the arguments. All right, so let's look at some examples of here applying this property here. So let's see, applying the product rule. Product rule. Okay, so the way we could do that is, let's say log base 6. Again, I just chose 6 at random. It works for any base b where b is just any value greater than 0. Okay, so here a, b, c, right, where they're just arbitrary values, right, a, b, and c. So what this tells me is that I can, since these are a product of 3, even though I did this pairwise, this will work across 3 numbers. This is equivalent to saying log base 6 of a plus log base 6 of b plus log base 6 of c. All right, and in the same way, if we started on the other end, let's say that I started with log base 7 of 18 plus log base 7 of x plus log base 7 of y. Okay, now these must be the same base, right? If it isn't the same base, different values, rules do not apply. Okay, and then here the product rule tells me that I can compress this into one log where I multiply all of these 3 terms, right? And only because it's plus here. So this will be log 18xy. And that is the product rule. Okay, so now you may be asking, well, what if it was minus, right? What if there was a coefficient here? Okay, good. Those are good questions, and we have other laws that we will go over in these next few videos that will resolve all of those issues, right? And now if we have, no matter what the operations are, we can compress it into one logarithm, or vice versa, right? You can go the other way, expand.